So in this video, we're going to talk about the measurements of dispersion. In the previous video, we looked at measures of central tendency. So this is now, instead of looking at what points our data are clustered around, now we're going to look at the spread of our data, hence the term dispersion. And what we're going to talk about really three different measurements, but two of them actually are going to differ depending on if the information that we're looking at or the data that we're observing is considered a population or is it a sample. And those three are range, variance, and standard deviation. I'll explain them in terms of what they represent once we show the calculations, but very similar. I'm going to show you a couple different ways of calculating these based off of our data, and then you can kind of choose which one you feel more comfortable. Okay, so the first one is range, which is a simple measurement, and all it's doing is it's telling us the difference between our maximum value and our minimum value. So a couple ways of doing that are we can type in our values. So our max value, and what we could do is we can highlight. I'm just going to use age here. So I can go ahead and do my max value, which is going to be 73. Now this one would be pretty easy to just look at if you scroll down because it's in numerical order for age, and we see that 73 is the highest age. But then I can also find my min value, and I can highlight, and obviously it's 21, but if we're dealing with a bigger or larger data set that isn't in order numerically, we have our min value and our max value and our min value. So our range is going to be the difference between those two values. So we have a range of 52. So range is a simple way of looking at dispersion, but really it's not a really good accurate measurement of dispersion, simply because it's only looking at the minimum value and the maximum value. It's not looking at the values in between. So since that's a very non-accurate description of dispersion, we're going to take a look at two that are more accurate, and those are variance and standard deviation. We're going to take a look at variance first, but I do want to mention that variance, we really don't report out variances simply because the measurements, when we're doing the math, if you look at the formula, our end result is actually going to be in units, the squared units. So in this case, if we want to know what the variance is of our age, it's actually going to be in squared years, which really doesn't mean anything to us, right? So I'll show you here just by doing the formula, once again, kind of explain it. But the way of looking at variance is that it is the, well, we'll actually get into that once we get into the formula. So there's a couple ways of doing this. Now, there's a difference between when we're dealing with variance and standard deviation. There are going to be different answers depending on if it's population data or sample data. So let me explain. Let's say that this data here is of every car that was sold in that month. So therefore, this is population data. So if this is population data, what we want to do is we want to find the population variance of this data. So what I'm going to do is I'm going to go to my more function, statistical, and I'm going to go down to standard dev of a population. So alphabetical order, and we see standard dev.p, and that's our standard deviation of a population. Here we have standard deviation of a sample, but right now we're going to stick with this formula here. So the first thing they want is actually what our data is. So we're going to use age, and I'm just going to highlight that. And we have a variance of 10.51 squared years, which once again, that means nothing. Sorry, population variance. So that really means nothing, right, in terms of reporting, because we want them in units that we are going to understand in terms of measuring. So what we're going to do is, instead of looking at variance, we want to know, instead of looking at squared years or years squared, we want to look at it in simply years. And the way we do that is by doing the standard deviation of a population. Okay. Now, once again, very similar. Go to the more functions, statistical, and go to standard dev, PQRS, standard dev of a population. I think I actually did that wrong. Actually, I'm going to go back and do that one because this is going to be 10 years. So let me go back. Let me finish this up. And we do have that 10.51 years. I did standard deviation when I actually wanted to do variance. So what I want to do is I'm actually just going to type in var of a population. And now I have 110.51 years squared. And the actual measurement of dispersion that makes sense would be the standard dev of a population, because once again, this is converting the population variance, which is in squared years, and we're taking the square root of that to calculate the standard deviation, which is 10.51 years. So the way of explaining standard deviation of would be it's the average distance our data is away from the mean. Okay, so average distance away from the mean. So what this means is the higher the standard deviation, the more dispersed our data is from the mean or from the center. The lower our standard deviation, the less spread or less variance that we have. Okay. Now, so that's just one way is by going through the formulas. I did mention about the equals, and then we can actually do if I want to do variance, I could do var p and then highlight my data, which is going to give me the same answer. It's just a different way of doing so. And for standard deviation, I could do standard dev. Oh, I got to do equals standard dev of a population. Double click and highlight, and now I have the standard deviation of the population by actually calculating it. Okay. So this is once again the measure. So we have our range up here, which is the difference between the min and max values. The variance is a measure of dispersion that takes in consideration all data points, and with all data points, but the answer that we get from our variance is actually going to be once again in the units squared or squared units. So that's not a good measurement of dispersion for us because we want to compare apples to apples. So the way we do that is we want to convert a standard or a population variance into a standard deviation of a population. And the way we do that mathematically is we take the square root of this in order to get the standard deviation of a population. But instead of doing it in multiple steps, we can simply go to our standard deviation of a population formula and go ahead and highlight our data and get our answers. Okay, so this is once again reporting population. Now, that's on the other hand, let's say that this data was, and what do we, how many units, or how many we have, let's see, there's 180. So there's 180 pieces of data here. So let's say that this is a sample of what was sold in a month for this car dealership. So what that means is now this is actually sample data. Now, a range is not going to change if it's population or if it's sample data. The range is still going to be 52 because it's the difference between the max and the min. But our variance, we're actually going to have a sample variance, and we will have a sample standard dev. Okay. So that's what we're going to take a look at. We're going to take a look at those, how we calculate those. So we can actually follow the function way of going through statistical, go to variance, do that. So statistical, scroll down to variance, LMP, QRSTV, QRSTV variance of a sample, and I'm going to highlight my data. And I'm going to hit enter, and I have a sample variance of 111.13 years, squared years. So look at the difference between the population variance and the sample variance. So the reason for this, why the sample variance will always be greater than the population variance of this if you're looking at the same data and doing the same formula, is simply because if you know all of the information of a population, this 110 is going to be 100% accurate because you're taking all data points into consideration. With a sample variance, the data that we're given is just a sample, meaning there's other pieces of data that we do not know. So the sample variance is actually taking that into consideration. And what it does is it's adjusting for that error. So what you'll see is the spread of our data, because we don't know that unknown, it's actually going to increase the variance of our data points. Okay. So that's one way. Another way is just once again doing the variance of a sample, actually typing it in, highlighting, and hitting enter. And now we have the same answer. Now for standard deviation, sample standard deviation, once again, we could take the square root of these values, but we have the function, so we can actually go to our statistical, we can go to our standard deviation, PQRS, standard deviation of a sample, highlight our data, and now we have our standard deviation of a sample. And once again, notice it is going to be slightly bigger than our population because of that unknown sets of data. But it is in the units that we want now, in the sense that it is in years. So the standard deviation is 10.54 years, or the average distance away from the mean that our data falls is 10.54. And we can also do this again with standard D of a sample and highlight our data. And now I'll hit enter. Now, so that's two ways. Now, I did show you in a previous video when we were doing the mean, median, and mode and you added it onto your computers, is that we can actually also use to find sample variations, variances and sample standard deviations by doing the data analysis or running the data analysis. So descriptive statistics, click OK. My input range, and I'm going to highlight that age once again. The reason why I'm highlighting that is because there is a box to check that says label in the first row. My output range, I'm going to select. I don't want it in a new worksheet. I want it in my existing. So I'm going to click there and then over here. And I'm going to click a box and I will click J4 and I want summary statistics. Right, so make sure all these are checked. Make sure when you click that output range that you're clicking in here before you select the cell that you want it in. And I'm going to click OK. Now, what do you notice is that, once again, the mean, the median, and the mode are all there of our data. But if you look at the standard deviation and you look at the variance, these, once again, are of a sample size. So 10.5419, that's our here, and then our sample variance is here. So when you're running this, oh, also the range, sorry, the range is also down here at 52, okay? So really useful tool, but if you're running this report to get your answers, just be aware that no matter if this is a population or a sample data, the mean, median, and mode are going to be correct. But when we run descriptive statistics, the program Excel looks at this as a sample. Hence is why you have these sample results. If you want to run it and then do the population next to it, so I would do the variance of a population. Oh, sorry, that's the standard deviation. So I'll do standard dev of a pop and highlight my data. So then what I can do is I can actually have all of my information there, and then the same thing with my variance of a pop and highlight. Now for these, once again, I'm only highlighting the data sets, or the actual data that is going to be used, not the heading. Because the heading, if you highlight the heading when calculating these, it's not going to know what to do with that age. So here we have our mean, median, and mode of a population or a sample. Here we have our standard deviation, our variance, and our range of a sample, and we have our standard deviation, variance, and range of a population. So these are the measurements of dispersion. If you guys have any questions, I highly recommend you can actually do this report with the profits. So you're not going to be able to do a standard deviation, variance, or range with location, vehicle type, because we're looking at that qualitative data. This is going to work with our quantitative, our numbers. Okay. If you guys have any questions, please feel free to reach out to me about this. But that is our measures of dispersion.